In practice, what are the main uses for the yield from syntax in Python 3.3? I'm having a hard time wrapping my brain around PEP 380. What are the situations where yield from is useful? What is the classic use case? Why is it compared to microthreads? So far I have used generators, but never really used coroutines, introduced by PEP 342. Despite some similarities, generators and coroutines are basically two different concepts. Understanding coroutines, not only generators, is the key to understanding the new syntax. MHO coroutines are the most obscure Python feature. Most books make it look useless and uninteresting. Thanks for the great answers, but special thanks to Agf and his comment linking to David Beasley presentations.
Let's get one thing out of the way first. The explanation that yield from G is equivalent to for V in G column yield V does not even begin to do justice to what yield from is all about. Because, let's face it, if all yield from does is expand the for loop, then it does not warrant adding yield from to the language and preclude a whole bunch of new features from being implemented in Python 2.x. What yield from does is it establishes a transparent bidirectional connection between the caller and the subgenerator. The connection is transparent in the sense that it will propagate everything correctly too, not just the elements being generated, for example exceptions are propagated. The connection is bidirectional in the sense that data can be both sent from and to a generator. If we were talking about TCP, yield from G might mean now temporarily disconnect my client socket and reconnect it to this other server socket. BTW, if you are not sure what sending data to a generator even means, you need to drop everything and read about coroutines first. They're very useful. Contrast them with subroutines, but unfortunately less are known in Python. Dave Beasley's Curious course on coroutines is an excellent start. Read slides 24 to 33 for a quick primer. Reading data from a generator using yield from. Instead of manually iterating over reader, we can just yield from it. That works, and we eliminated one line of code. And probably the intent is a little bit clearer or not. But nothing life-changing. Sending data to a generator, coroutine, using yield from, part 1. Now let's do something more interesting. Let's create a coroutine called writer that accepts data sent to it and writes to a socket, FD, etc. Now the question is, how should the wrapper function handle sending data to the writer, so that any data that is sent to the wrapper is transparently sent to the writer? The wrapper needs to accept the data that is sent to it, obviously, and should also handle the stop iteration when the for loop is exhausted. Evidently just doing for x and coro column yield x won't do. Here is a version that works. Or, we could do this. That saves 6 lines of code, make it much more readable, and it just works. Magic. Sending data to a generator yield from, part 2, exception handling. Let's make it more complicated. What if our writer needs to handle exceptions? Let's say the writer handles a spam exception and it prints if it encounters one. What if we don't change writer_wrapper? Does it work? Let's try. It's not working because x equals yield just raises the exception and everything comes to a crashing halt. Let's make it work, but manually handling exceptions and sending them or throwing them into the subgenerator writer. This works. But so does this. The yield from transparently handles sending the values or throwing values into the subgenerator. This still does not cover all the corner cases though. What happens if the outer generator is closed? What about the case when the subgenerator returns a value? Yes, in Python 3.3+, generators can return values. How should the return value be propagated? That yield from transparently handles all the corner cases is really impressive. Yield from just magically works and handles all those cases. I personally feel yield from is a poor keyword choice because it does not make the two-way nature apparent. There were other keywords proposed, like delegate, but were rejected because adding a new keyword to the language is much more difficult than combining existing ones.
What are the situations where yield from is useful? Every situation where you have a loop like this. As the PEP describes, this is a rather naive attempt at using the subgenerator. It's missing several aspects, especially the proper handling of the .throw, .send, .close mechanisms introduced by PEP 342. To do this properly, rather complicated code is necessary. What is the classic use case? Consider that you want to extract information from a recursive data structure. Let's say we want to get all leaf nodes in a tree. Even more important is the fact that until the yield from, there was no simple method of refactoring the generator code. Suppose you have a senseless generator like this. Now you decide to factor out these loops into separate generators. Without yield from, this is ugly, up to the point where you will think twice whether you actually want to do it. With yield from, it's actually nice to look at. Why is it compared to microthreads? I think what this section in the PEP is talking about is that every generator does have its own isolated execution context. Together with the fact that execution is switched between the generator iterator and the caller using yield and _next_, respectively. This is similar to threads, where the operating system switches the executing thread from time to time, along with the execution context, stack, registers. The effect of this is also comparable. Both the generator iterator and the caller progress in their execution state at the same time. Their executions are interleaved. For example, if the generator does some kind of computation and the caller prints out the results, you'll see the results as soon as they're available. This is a form of concurrency. That analogy isn't anything specific to yield from, though, it's rather a general property of generators in Python.
Wherever you invoke a generator from within a generator, you need a pump to re-yield the values, for v in inner_generator column yield v. As the PEP points out, there are subtle complexities to this which most people ignore. Non-local flow control like throw is one example given in the PEP. The new syntax yield from inner_generator is used wherever you would have written the explicit for loop before. It's not merely syntactic sugar, though. It handles all of the corner cases that are ignored by the for loop. Being sugary encourages people to use it and thus get the right behaviors. This message in the discussion thread talks about these complexities. With the additional generator features introduced by PEP 342, that is no longer the case. As described in Greg's PEP, simple iteration doesn't support send and throw correctly. The gymnastics needed to support send and throw actually aren't that complex when you break them down, but they aren't trivial either. I can't speak to a comparison with microthreads, other than to observe that generators are a type of parallelism. You can consider the suspended generator to be a thread which sends values via yield to a consumer thread. The actual implementation may be nothing like this, and the actual implementation is obviously of great interest to the Python developers, but this does not concern the users. The new yield from syntax does not add any additional capability to the language in terms of threading, it just makes it easier to use existing features correctly. Or more precisely, it makes it easier for a novice consumer of a complex inner generator written by an expert to pass through that generator without breaking any of its complex features.
A short example will help you understand one of yield from's use case: get value from another generator.